We will see soon that DFMA has strong links with other concepts of systematic design. And again, ideal final result from trees seems to be the champion and holds the general idea. Ideally, the product assembles itself, right? DFMA is often associated with lean because it's all about identification, quantification, and elimination of wastes or inefficiencies in product manufacturing. I'm sure you can speak some Japanese like Pokayoki, Muda, or Kanban. I would only notice that lean principles are mostly meant for non-engineering part of design world, mostly managers. These principles are softer, more common sense based, more strategic. I am sure that nothing can beat a good example to tell what is the main idea of DFMA. Here are three fighters of World War II time. And please, you don't need to be an aerodynamic expert. Let us just check our intuition. But what do you think? Which plane could fly better? More maneuverable, powerful, higher speed? Yeah, it was number 3, legendary British Spitfire. Excellent aerodynamics, performance due to elegant curves of the body. Now, what do you think? Which one was easy to manufacture, to produce, to assemble? Right, that was number 1, German Messerschmitt 109. Straight line, square elements, flat glass on the cockpit, and the cannon that could now fire through the hollow propeller. It made it the classic of DFMA. The consequences were really impressive. And here are the numbers. Messerschmitt required just 1/3 of Spitfire time to be manufactured. 1/3. Thus, there were almost twice more Messerschmitts in the sky produced over even shorter period of time. How to make a system more manufacturing friendly? And there are 3 strategies that are quite obvious. First, we have to simplify the design. We have to reduce the part count. That is completely overlapping with trimming exercise and the goal of trimming from trees. Second, we have to use cost-effective materials and cost-effective processes in production. And the third, we have to minimize the complexity of manufacturing and assembling operations. Let us develop it a little bit more. If we focus on a specific component, one element of our design, we can reduce assembling time if we, first, eliminate or minimize tangling between parts in the feather, so it is easy to pick up. Second, we can make it symmetric. Symmetry will reduce orientation time during handling. And the third, if symmetry is not possible, we can use obvious features to speed orientation. Well, for example, we can magnetize, we can put markers. We can also have a quick checklist just to check if we need the part as a separate element at all. Question 1. Does the component move with respect of other parts that has already been assembled? And question 2. Must the part be made from a different material or isolated from all other parts already assembled? If the part does not meet any of these 2 criteria, it is a candidate for elimination or consolidation. That means merging with other parts. They can be one. If we focus on the system as a whole, there is another DFMA checklist. 6 points. First, reduce the number of parts when possible. Remember trimming. Second, build the part in layers from the top to the down using gravity to locate parts. So it is easy, thanks to gravity, to put them one after another. Think of sub-assembling. Third, have already assembled products stable on the workspace. For example, magnetize. Fourth, have the work lie in horizontal plane, so it is easy to move in the workspace. Equipotentiality. Fifth, use chamfers and fillets to ease mating of parts, so it is easy. It is coming to each other itself. And the last one, use snap fits, click systems, and other quick fasteners, avoiding screws, glue, welding, and so on.